At 2:14 in the Strait of Hormuz, the USS Carney comes alive. A rapid launch of RIM-174 Standard Extended Range Active Interceptors tears into the night, their solid rocket boosters shaking the hull as they surge toward Mach 4 within seconds. The target, 3 Iranian Noor cruise projectiles skimming barely 10 feet above the water, closing in near a fully loaded Suezmax tanker. The margin for error is almost non-existent. If the SM-6 Seekers fail to lock on in the next 11 seconds, hundreds of millions of dollars in global energy could turn into a major environmental crisis. This is not a drill. It is the carefully calculated collapse of a $3.2 billion Iranian provocation. Tehran has just tested the Fifth Fleet, and in the next 12 minutes, it is about to see its entire maritime strategy taken apart piece by piece. For years, the IRGC poured resources into underground launch complexes, coastal batteries, and Shahed Soleimani-class corvettes, all designed to challenge U.S. Navy escorts in one of the world's most important waterways. Their assumption was simple: make the Strait of Hormuz too risky, too expensive, and too politically complicated for the United States to protect. That assumption was about to fail. The moment IRGC vessels moved into shadowing positions around the tanker convoy, they did more than create pressure. They created a target picture. The American response was not a strongly worded message. It was the activation of an integrated engagement network. While Iranian captains were still shouting commands over exposed radio channels, a KH-11 Kennan satellite hundreds of kilometers above the Earth had already passed their thermal signatures into the U.S. Navy's command system. On board the USS Abraham Lincoln, the tactical action team was no longer guessing. They were tracking. The Iranians believed they were setting the pace. In reality, they were already inside the system before they had fully cleared the harbor. Tehran's $3.2 billion strategy depended on volume. The plan was to overwhelm American defenses with coordinated pressure from sea, shore, and air. But the U.S. Navy answered with something more powerful than volume: information dominance. The instant those 3 projectiles left their rails, AGM-158 CLR-ASM strike options were already being prepared. And that is where the entire situation shifted. The U.S. did not simply respond to the immediate threat. It used the threat's own radar activity to reveal the hidden network behind it. Every coastal battery, every signal source, every concealed position in the limestone cliffs began turning into data. Tehran thought it had built a trap. Instead, it had given the U.S. Navy a $3.2 billion reason to demonstrate why control of the Strait of Hormuz still depends on sensors, coordination, and speed. The Iranian corvettes were now operating inside a total information blackout. Their crews were trying to track targets that did not exist, created by American electronic warfare systems. Meanwhile, the real RIM-174 interceptors were already closing the distance. The bold challenge had turned into a very expensive lesson. At 02:16, the Iranian corvettes attempted to lock their fire control radars onto the lead U.S. destroyer. That was the trigger. High above the Gulf, an EA-18G Growler moved into position. The aircraft's electronic warfare suite came online, and the battle space changed instantly. With the ALQ-218 tactical receiver feeding data into the system, Iranian radar screens did not simply lose clarity. They became overwhelmed with false returns. The U.S. Navy was not just blocking signals, it was reshaping the picture. On Iranian displays, one American ship became 50. False tracks appeared from the north, south, and east at the same time. Approaching threats seemed to come from every direction, while the real formation remained hidden behind layers of digital confusion. This is the power of next-generation electronic warfare. It does not need to overpower every system at once. It identifies the exact frequencies, behaviors, and weaknesses of enemy hardware, then turns that equipment against the people relying on it. Within moments, the $3.2 billion Iranian fleet was isolated, disoriented, and cut off from its digital backbone. They're trying to aim manually, a sensor technician aboard the USS Carney reported. They've lost the data link. And that was the decisive break. They could no longer coordinate with their ships at sea. The U.S. had effectively cut off Iranian command and control, but the IRGC, under pressure to avoid embarrassment, launched a volley of land-based cruise missiles anyway. That was the moment the entire system proved why it was built differently. The USS Carney did not wait for the incoming projectiles to appear over the horizon. Far above the Gulf, an E-2D Advanced Hawkeye was circling at 30,000 feet, watching the launch activity from beyond the curve of the Earth. Through Link 16, the Hawkeye passed targeting data directly to the destroyer's vertical launch systems. The destroyers did not even need to rely on their own radar first. They launched using the Hawkeye's picture of the battle space. From the VLS cells, RIM-174 Standard Extended Range, active interceptors surged into the night. The SM-6 is a $4.8 million piece of precision engineering, moving at more than 2,600 miles per hour. It does not simply fly toward a fixed point. Its active radar seeker, adapted from air-to-air technology, allows it to track and adjust against maneuvering threats with remarkable independence. Within 40 seconds, all 3 Iranian inbound cruise missiles were stopped before they could reach the tanker convoy. In the darkness, the intercepts appeared as quick flashes above the water. The sound and light of $3.2 billion in strategic pressure fading into scattered metal fragments. But the U.S. Navy did not limit itself to defense. In modern maritime conflict, simply absorbing pressure is never enough. The decisive part of the American response was the counter-battery phase. Once the Iranian corvettes realized their launch attempt had failed, they turned back toward the shallow coastal waters, believing those areas would protect them from larger U.S. warships. They had miscalculated again. From F-35C aircraft, AGM-158C LRASM anti-ship missiles were released. The LRASM is one of the most advanced weapons in the U.S. inventory, designed to operate even when GPS is being disrupted. Instead of depending only on satellite guidance, it uses imaging infrared sensors and onboard processing to recognize enemy vessels by comparing them with a stored target library. The LRASM skimmed low over the waves, moving fast and quietly beneath radar coverage. It did not simply aim for the outline of the ship. It selected the most critical point and delivered its payload with extreme precision. While the surface engagement unfolded, another platform was already in position beneath the waves. The USS Florida, an Ohio-class guided missile submarine, had been waiting silently for 6 days, completely undetected. At the Admiral's order, the Florida launched a sequence of BGM-109 Tomahawk land attack missiles. The Tomahawk, at roughly $2 million per unit, gives the U.S. Navy long-range precision from nearly anywhere. These were not aimed at the ships, they were aimed at the coastal launch infrastructure itself. The missiles followed the shape of the Iranian coastline, moving low through the valleys near the Zagros Mountains at around 550 miles per hour. Their goal was not the mountain face. Their goal was the ventilation shafts, access points, and reinforced entrances connected to the underground launch sites. The secondary blasts from stored munitions were powerful enough to register across local maritime sensors. The message was unmistakable. Hiding underground or inside coastal terrain did not guarantee safety from an engagement network moving at digital speed. By 2:26, only 12 minutes after the first radar contact, the engagement was effectively over. The Iranian Shahed Soleimani-class corvette, once presented as the pride of a $3.2 billion modernization effort, was disabled and burning. 2 additional fast attack craft had been taken out of the fight by RIM-162 ESSM interceptors. The ESSM is the Navy's close-range specialist, built to respond to fast-moving threats inside the carrier's defensive zone. With extreme maneuverability and rapid reaction time, it is designed to stop anything that breaks through the outer layers. The economic result was devastating for Tehran. In 12 minutes, Iran had lost a major portion of its modern naval capability and several key coastal battery sites. The U.S. Navy, by comparison, had used only a tiny fraction of its available magazine depth. That was the true imbalance of the engagement. For the Iranian crews, it was confusion, pressure, and the sudden collapse of everything they had trained to rely on. For the sailors aboard the USS Abraham Lincoln, it was procedure. Inside the Combat Information Center, the tactical action officer checked his watch. Targets neutralized, convoy clear, resume standard patrol speed. There was no celebration, no shouting, no dramatic pause, just another entry in the logbook. He simply took a sip of lukewarm coffee and started the paperwork for the mission debrief. To make sure the remaining Iranian submarines did not attempt one final reckless move, the USS Carney launched a RUM-139D. This weapon is a hybrid system, a rocket that carries a Mark 54 torpedo. The rocket delivers the torpedo several miles away within seconds. Then the torpedo enters the water and begins an active acoustic search. The Iranian Ghadir-class submarine heard the Mark 54 enter the water nearby and immediately reacted. Within moments, it performed an emergency surfacing procedure and rose above the waves, signaling surrender. Its crew understood the reality of the situation. Inside this system of systems, disappearing was no longer an option. What made the U.S. Navy's response so overwhelming was not only the precision of the strike. It was the electronic pressure that remained afterward. For the next 48 hours, the U.S. Fifth Fleet maintained near-total electronic control over the Persian Gulf. American aircraft stayed on alert, supported by AGM-88 HARM systems. The AGM-88 is designed to detect hostile radar emissions. The moment an operator activates a radar system, the weapon can track that signal and race toward the source at extreme speed. Tehran was effectively left in the dark. They could not reliably communicate with their remaining ships. They could not clearly monitor tankers moving through the strait. They could not even coordinate their own defensive network without risking exposure. The $3.2 billion modernization effort was supposed to buy them security. Instead, it gave them a front-row seat to the limits of their own system. The U.S. Navy brought together 3 carrier strike groups, the Lincoln, the Ford, and the Bush, creating a wall of maritime power stretching from the Gulf of Oman to the North Arabian Sea. But this concentration of force was not just about the number of ships or aircraft. It was about the information advantage. When 3 carrier groups connect their Aegis systems, they create one shared radar picture covering a massive area. Civilian aircraft, fishing vessels, small boats, and unmanned systems can all be tracked, labeled, and identified in real time. For the U.S. Navy, there is no confusion in the battle space. There is only data waiting to be processed. And while the technology is impressive, the real advantage revealed in this confrontation was training. The IRGC operates through a rigid top-down command structure. A captain at sea often depends on approval from commanders ashore, who may need authorization from even higher levels. In a high-speed engagement where threats move faster than decisions can travel up and down the chain, that delay becomes a critical weakness. The U.S. Navy works differently. Its doctrine is built around distributed lethality and delegated authority. The tactical action officer aboard the USS Kearney, a 28-year-old lieutenant, has the authority to respond immediately to anything that threatens the ship or the convoy. He does not wait for Washington. He does not pause for a distant committee. He follows the engagement process he has practiced thousands of times in simulators. That autonomy allows the U.S. Navy to move faster than the enemy's decision cycle. Observe, orient, decide, act. By the time IRGC leaders in Tehran were being awakened with news of the first intercept, the outcome at sea had already shifted beyond their control. The sailors are the human processors inside this vast machine. They are not just operating weapons, they are managing a stream of information that would overwhelm an untrained crew. But the Aegis combat system turns that complexity into clear choices. Track or ignore, engage or hold, protect the convoy or reposition the screen. That is the uncomfortable reality for Iran. In this kind of confrontation, they are not facing just a fleet. They are facing a network decision system that studies every move, predicts the next one, and prepares a response before the opponent can regain control. They did not need to put a single soldier on Iranian territory. They simply removed the systems Iran had been using to pressure one of the world's most important shipping corridors. For the global shipping industry, the effect was immediate. Risk calculations changed. Insurance costs began to fall. The Strait of Hormuz had not been stabilized through negotiation, but through a clear demonstration that the maritime route could still be protected. When the IRGC challenged the U.S. escort operation, they believed they were creating a trap for a power they saw as weakened. What they failed to understand was that, for the U.S. Navy, an escort mission is also an intelligence-gathering opportunity. Every tanker in the convoy becomes more than cargo. It becomes a moving test of the opponent's sensors, communications, and reaction time. The moment hostile systems activate, they reveal themselves. Once they reveal themselves, they can be tracked, analyzed, and, if necessary, taken out of the equation. By 400, the first light of morning began to rise over the horizon, turning the Arabian Sea into a sheet of hammered gold. The tanker convoy, still under the protection of the USS Abraham Lincoln, continued its transit. The massive crude carriers moved slowly across the water like floating islands. Their decks were quiet. Their crews were safe. The route remained open. Behind them, the smoke rising from the coastal launch sites was the only visible sign that the engagement network had ever come online. In less than one night, the message had been delivered with absolute clarity. Modern naval power is not only measured in ships, missiles, or aircraft. It is measured in sensors, speed, coordination, and the ability to act before the other side fully understands what is happening. The Strait of Hormuz remained open because one side brought pressure and the other brought a fully connected force. And that is the reality of modern warfare at sea. The side that sees first, shares first, and acts first does not simply respond to the battlefield. It shapes it.